Afternoon, ladies and gentlemen. My name is Paul Hanna, and I'm here to pitch my concept, Ezimon, easy plug-and-play condition monitoring. So before I get into the pitch itself, most of you won't have heard of condition monitoring, so I just want to give you a basic idea of what condition monitoring is, and what you're hearing there, or not hearing anymore, is what you'll all have heard, or most of you will have heard if you walk into an industrial site. And that noise, or more importantly, the vibration that's causing that noise, can be used by professionals, condition monitoring professionals, to find out an amazing amount of information about what's going on inside each one of those pieces of equipment. So they're able to tell you, just by listening to that vibration, what's happening to that piece of equipment and what's going on inside. What's wearing, what's ready to break, what's starting to fail. And the reason that's important, apart from saving, because you don't want things to fail unexpectedly. The reason you don't want things to fail unexpectedly is it causes injuries, and probably more prosaically for business, it costs you money. The last thing you want is for something to fail at a moment you don't expect it to. So how did this project get started? Well, I was over in the UK doing a PhD and a postdoc involved with Rolls-Royce, and we were looking at condition monitoring in jet engines with them. Following that, I moved back to Australia and I was working in industrial engineering, software mainly, and with condition monitoring in a number of different projects, and I saw a huge gap in the market. And as a result of the work we were doing at Rolls-Royce, and what I saw was that with advancements in technology, faster processing, cheaper components, and the arrival of cloud computing, what we were doing with Rolls-Royce on supercomputers could be done in the cloud on very cheap consumer-grade equipment. So what is the problem? The problem is, with condition monitoring, the problem is that it's expensive. You need high-quality gear, you need expert knowledge, and you need in-depth analysis. Each of those three things increases the cost. The last two invariably means that you have a strong dependency on experts and humans in the process. So what's the opportunity? Well, currently, less than 5%, and I'd say that's an overestimate, of rotating equipment is valuable enough to justify condition monitoring. The return on investment just isn't there for the rest of the equipment in an industrial site. Another 80% could benefit from condition monitoring, but the condition monitoring is too expensive and too difficult to make sense. The global machine condition monitoring market is expected to reach over $2 billion in 2015. And it is one of the few industries to flourish in adversity, which is very important in our current economic climate. This is a quote by a senior engineer at Queensland Alumina Limited, a huge aluminium refinery in Gladstone. This has wide applicability in heavy industry. We alone, that site alone, would have several thousand pieces of equipment where this technology could be applied. Full commercialization of this technology would be of great interest through our business and industry. And I want to just concentrate on that second line. Several thousand pieces of equipment, which currently have no condition monitoring at all because it's too expensive. What I'm going to present to you today has the potential to revolutionize that. So what is our solution? Well, the first thing is we use consumer-grade equipment, which significantly lowers the cost. And we leverage technology to bring the quality of that condition monitoring up to scale. So we use algorithms above hardware, and we remove humans from the process. And we have built-in scalability in the system. We combine cloud computing, the Internet of Things, artificial intelligence, and big data to remove humans from the process. The interface is very, very simple. That's the idea. It's straightforward. You aren't getting a huge amount of information. You're being told that everything's okay, or there's a warning, or there's an error. And go and look at that piece of equipment. So the benefits of the system are that it's plug and play. You take the piece of equipment, you plug it onto the machine, and then you forget about it. It's zero config. Again, 10 minutes and you're done. Off-the-shelf components, priced at an impulse buy price for industry. We've removed all the barriers. Thank you very much. What am I looking for? Well, I'm not looking for funds at the moment. At the moment, I'm self-funded, but I am chasing advisors in marketing, product development, and scale-focused sales. Thank you very much.
Well done. Great stuff. Questions from the panel? Rick?
Where are you plugging in your deep learning?
It's artificial intelligence research that I developed while I was doing the postdoc at Rolls-Royce and with Manchester University, and that is actually doing the analysis. So the data is coming from the physical device on site, being uploaded to the cloud, and then that analysis is being done remotely in the cloud.
Right, and you're not using Alchemy API or any of those services?
No, no, it's a purely bespoke network that's running.
It would really be great if you started off the demo with an example showing it working, because we kind of like got the idea of what direction you're going, but if you just say, hey, here's a smartphone with this device hanging off it, this is what it's analysing, and this is the machines it's listed. So, because I get it, but and I can understand the potential of the thing, but when you've been doing something for a long time, sometimes you lose perspective of how the simple message is often the best one just to start out with.
Yeah.
Says me, I'll probably bamboozle everyone here in a few moments, but anyway.
Excellent. Thanks, Rick. Any more questions? Matt Dickinson.
So, how much do the normal solutions cost?
In the thousands of dollars, thousands to tens of thousands of dollars. Yeah, they have to be calibrated industrial grade equipment because there is no smarts behind them. It's purely a level of vibration that if it goes over this alert me. It's very, very simplistic, and they're quite expensive. And usually you can't just buy them off the shelf. You have to bring in a salesman to design up a system for you and then go from there. And that was where that quote came from. That was his real reaction to this is it's fantastic, it's something we can just buy, fit to the equipment, and we don't need to go through a long, complicated process, an expensive process, a 2 or 3 month process to get this set up. It's just plug it in, set it up, and forget about it.
So that's thousands of dollars per piece of equipment you want to monitor?
Generally, yes.
Okay, cool.
It seems to me that you've got a significant pricing strategy issue, because on the one hand you've got competitive products that must cost thousands to implement if one does it all because of the high barrier to entry.
Yep.
At the end of the day, you're looking at a product that you can sell for $200.
Yep.
I'm just intrigued as to whether you think you're going to go out and sell it at that price, or is there some alternative that might give you a bigger share of the pie that you're creating as a value chain?
There's definitely, and that comes back to the advisors that I'm looking at. But definitely there'll be an issue of seeding it into the market and seeing what the market can take. One of the issues is that I'm not competing directly with these competitors. These competitors, while they cost tens of thousands and sometimes hundreds of thousands of dollars every year to do the job, this is on $15 million, $20 million pieces of equipment. I am targeting the other 80% of that equipment, where that kind of spend just doesn't get a return on investment. The effort and the spend and the complexity doesn't make sense. With this system, it's giving a simpler result, it's giving a simpler answer, but it's competing with, well, we're not going to do anything. It's not competing with the competitors, it's competing with nothing at all.
Can I just ask you,
Yeah.
So I'm just sitting thinking about a situation. I have a dirt bike. I know what it sounds like when a timing chain starts to wear, right? A lot of people don't know. So I could actually monitor the sound of it. There's databases of what a dirt bike, my model in good health is. It compares it and says, your timing chain starting to lose. Is that what you're talking about?
Take it down a step. It's basically saying something's not quite right.
Right.
Because you don't know what piece of equipment this is on.
But you have a database also that you can actually start to do
We
diagnostics.
don't know. That is the big data side of things. We do plan. That's one of the plans, is to start using that data.
Have you got a patent yet for it?
I haven't. No.
Okay.
That's it. Thank you. We're not going to start Rick on patents straight away. Thanks very much, Paul. That was fabulous. Last pitch of the day in this session before we head to a break is Myla. Thank you.